Good afternoon and welcome to NASA headquarters. I'm Steve Cole from the Office of Communications. A new type of Earth science satellite is in California right now, getting ready to launch into space in 2 weeks. NPP, the NPO's Preparatory project, will be NASA's first Earth observing satellite to measure both climate changes and key aspects of day-to-day weather. Today we have 4 speakers here to tell you more about NPP and its mission. Our speakers are, first, Andrew Carson, NPP Program Executive at NASA headquarters, Ken Schwer, NPP Project Manager at Goddard Space Flight Center, Dr. Jim Gleason, NPP Project Scientist at NASA Goddard, and Dr. Louis Uccellini, Director of the National Oceanic and Atmospheric Administration's National Centers for Environmental Prediction, representing the National Weather Service. The presentations will last about 15 minutes, after which we'll open up the floor to journalists here in the audience as well as online. So our first speaker, let me hand it over to Andy. Andy?
Thank you, Steve. We're very excited about the upcoming launch of NPP in just a few short weeks. NPP is a bridge to the next generation of Earth observing satellites that'll provide climate data that'll help that are critical to NASA's Earth science research. NPP will help us understand what tomorrow will bring, whether by tomorrow we mean tomorrow's forecast or whether we mean years or decades from now. NASA is currently operating 14 Earth science missions, including a series of satellites known as the Earth Observing System, or EOS. These satellites, Terra, Aqua, and Aura, provide measurements about land, oceans, and atmosphere. NPP will continue these key measurements, which are critical to understanding the health of our planet now, as well as how things might change in the future. NASA is taking what we learned from the EOS system and helping NOAA create the next generation of satellites to extend these measurements into the future through the Joint Polar Satellite System, or JPSS. NPP will lay the groundwork for JPSS by proving out the technologies and capabilities of that system, both in the instruments and the ground system. NPP data will also be incorporated into the National Operational Weather Forecast models, providing higher resolution data and improving the weather forecast capabilities. So NPP is a critical first step in building a climate-capable operational system. This mission was developed in collaboration with our partners at NOAA and the Department of Defense, as well as our industry partners at Ball, Northrop Grumman, Raytheon, and ITT. We are finishing up the last of the launch preparations for NPP and are looking forward to launch on October 27th. We expect it will become a significant part of our nation's climate and weather capabilities. Now I'll turn it over to Ken Schwer, the NPP Project Manager.
Thank you, Andy. Tomorrow is a monumental milestone for NPP. The NPP satellite will be mated on top of the Delta II launch vehicle out of Vandenberg Air Force Base, California, as we prepare for our October 27th launch. The NPP team has successfully maintained schedule the past 2 years while completing a comprehensive satellite environmental test program and ensuring the readiness of the ground system and the mission operations team. The NPP spacecraft is built by Ball Aerospace in Boulder, Colorado, where all 5 instruments were delivered and integrated onto the spacecraft. After integration, the NPP satellite is actually about the size of an SUV. The NPP team successfully completed a satellite pre-ship review and the mission operational readiness review back in mid-August. After that, the NPP spacecraft was then shipped from Boulder, Colorado via environmentally controlled spacecraft shipping container and a tractor trailer on August 28th, and approximately 30 hours later arrived at Vandenberg Air Force Base, California on August 30th. Since then, the NPP spacecraft and instruments has successfully completed all checkouts and preparations for launch. Over the next 2 weeks, the NPP and Delta II teams will conduct a mission dress rehearsal on October 21st and the launch readiness review on October 25th. The mission dress rehearsal actually exercises the satellite and launch vehicle teams with simulated anomalies while actually running the countdown procedure. This ensures the launch readiness of the satellite and the launch vehicle teams. The NASA Goddard Space Flight Center role for NPP is to manage the entire mission for NASA's Earth Science Division. This includes acquiring the spacecraft, 2 of the 5 instruments, working with the Kennedy Space Center for the Delta II launch vehicle, and overall mission systems engineering and early orbit operations. In fact, over the past 50 years, the NASA Goddard Space Flight Center has managed and launched over 260 successful missions into space. After launch, the NPP satellite will orbit 512 miles above our homes. It will actually be controlled from NOAA's Satellite Operations Facility in Suitland, Maryland. As you can see, I am very excited and proud about my NPP team's accomplishments, and we look forward to a great mission. Thank you. This time, I'd like to turn it over to Jim Gleason for the science overview.
Thanks, Ken. We are really excited to be here to be talking to you about the upcoming NPP launch, which is really the first mission that's designed to provide observations for both weather forecasters and climate researchers. It's incredibly valuable to try to understand what the future environment may be. And the future environment is as much tomorrow's weather as it is long-term climate. People often confuse climate and weather. Weather is what's going to happen tomorrow or this upcoming weekend. Climate is what happens over years and decades. So climate is long-term behavior, weather patterns over time. For example, these are the patterns that make it easier to grow corn in Iowa than in Arizona. So simply put, climate is what you expect, weather is what you get. And NPP's observations will help scientists to better predict the future environment. And these predictions are incredibly valuable for economic, security, and humanitarian reasons. NPP's observations will produce at least 30 data sets that will contribute to our understanding of all parts of the Earth system. For example, NPP will help us understand temperature and water in the atmosphere. NPP will help us understand how clouds and aerosols affect temperature. NPP will help us understand the ozone layer. And NPP will help us understand the biosphere, focusing on vegetation or plants on land and in the ocean. So why is NPP important to NASA? NPP is important to NASA because it continues over 40 years of Earth observations that NASA has been making. And in particular, NPP carries on the Earth observing satellites records from Terra, Aqua, and Aura, and hopefully the observations from the Joint Polar Satellite System will be added to NPP's data records. So NPP's observations will help NASA make better long-term data sets, which help scientists make better models, which then lead to better predictions, which hopefully can be used to make better decisions. And these decisions can be as simple as, do I bring an umbrella? Or as complex as, how do we respond to a changing climate? So again, NPP, better observations for better models, better predictions, and hopefully better decisions. And now I'd like to introduce Dr. Louis Uccellini of the National Weather Service.
Thank you, Jim. We've already heard about the potential of the MPP for improving weather forecasts. Now, the success of the weather forecast enterprise serving a weather-ready nation is dependent on 3 components: sophisticated numerical models run on the world's fastest computers, ingesting over 1 billion observations per day to make these weather forecasts every day. Now, the backbone for that global observing system is the polar satellite data that both NASA and NOAA have worked on for decades to improve the operational forecast systems. So the launch of the NPP is a big deal for America. NPP does represent a bridge from the current polar satellite systems to the future operational platforms known as the Joint Polar Satellite System, or JPSS. Now, the timing of this NPP launch could hardly be more appropriate. 2011 has been termed the year of the billion-dollar weather disasters. We've already had 10 separate weather events, each inflicting at least $1 billion in damages, including the tornado outbreaks, fires. We've had hurricanes that have affected the east coast of the United States, and we've had floods that have affected a large portion of the north central and central part of the United States. With NPP's advanced microwave, infrared, and visible data feeding NOAA's operational weather prediction models, we expect to improve our forecast skills and extend those forecast skills out to 5 to 7 days in advance for hurricanes, severe weather outbreaks, and other extreme weather events. We expect these advanced instruments on NPP and a high-resolution imager on this spacecraft to become a foundation for the global observing system that will be absolutely essential for NOAA's prediction models, especially for extreme events such as the recent occurrence of Hurricane Irene along the east coast of the United States. Beyond the weather forecasting, NOAA will use NPP data to track ash plumes from volcanic eruptions to enhance aviation safety, monitor crops, vegetation, potential for drought and fires, measure variation in the Arctic sea ice, and detect harmful algal blooms and other hazards that might endanger fisheries and fragile ocean ecosystems. NOAA is really looking forward to a successful launch. I am excited about the potential for NPP and its use in the operational numerical weather prediction models. Back to you, Steve.
Okay, thank you. Thank you to all our speakers. We'll take questions from the media in just a minute, both in the audience. If you have a question, please raise your hand. A microphone will come to you. Or if you're on the phone lines, you dial *1. But first, I wanted to remind everybody watching and listening that there's a lot more information about NPP online on the NASA website, which is www.nasa.gov/NPP. You can keep up with the launch milestones all the way up through watching launch on that website. Okay, so we'll see if we have any questions here. Any questions in the audience? Okay, first.
Hi, this question is addressed to Louis. What advances in the new system with respect to the sounders are in place in NPP that differ and increase the capabilities in the current satellite system?
Well, the NPP has an advanced microwave sounder and the infrared, which is a CRIS, which is basically equivalent, a slight improvement over what we're using from the MEDOP, the European satellites. So we have experience with these sounders, and what this will allow us to do is, because this will be at a different orbit than what we have for MEDOP, we'll be able to have that type of advanced observations that will help us fill in data gaps in a temporal sense over the entire day.
You're probably aware of a recent article in JAS, I believe, I forget who the authors are, who argue that the resolution, at least of the current sounders, and I'm not quite sure if this is true for the NPP and advanced JPSS equipment, is insufficient for input and value into high resolution forecast models. Do you have any comment on that?
I think that we've already shown with the use of the current advanced systems that the resolution of those instruments are not only sufficient, they meet all our requirements with respect to the global models. And as you get down to the mesoscale, we can use those global models to help force the mesoscale initial conditions. So I don't really. Well, we're also assimilating the satellite data into those higher resolution models as well. As you know, we don't have any data sets that match the resolution of those high resolution models. The real trick of data assimilation is to take the strengths of observing systems and make them applicable to any resolution in those models, and we've been successful in doing that. So I really don't see that as an issue.
Okay, we have another question here. Please identify yourself.
Hi, I'm Mary Orndorff with the Birmingham News. I guess this question is for NOAA. How long will the NPP last, and what is the latest on what it will be replaced with, and whether or not there'll be a gap in that weather coverage?
Well, actually, in terms of expected lifetime, it has to go over to the project, but we're hopeful that it'll be 5 years and beyond. But let's get the.
Yes, it's always hard to predict how long satellite is going to live. I can tell you that the instruments were designed under the NPOS regime for a 7-year lifetime. However, during manufacturing, testing, and calibration of these instruments, significant anomalies arose that give us concern that there's residual risk with these instruments that could actually affect the on-orbit lifetime. The instruments are performing well, but we are concerned about the on-orbit lifetime on some of these instruments. Keep in mind, NPP was always a pathfinder mission, and the lessons learned from NPP, we're going to go back into the design and manufacturing of these instruments for the follow-on operational program. It was always envisioned that it would take approximately like 18 months to go through the calibration validation of these instruments, and that would give NOAA time to update the data product algorithms for use on the ground so we can improve the data products before the operational system would be launched.
Okay, we have a question on the phone lines. Alan Boyle from MSNBC. Go ahead, Alan.
Hi. This mission comes after a years-long debate over OESS, and I wondered if you could reflect on how that whole debate turned out, so whether there were lessons learned from that, how you were going to avoid the mistakes in that process, and what you'd be missing because of the way that the mission has been used.
Alan, we lost a little bit of the last half of your question.
Yeah.
But go ahead, Andy.
Okay, I think I can address part of his question. As you know, back in February of 2010, the administration decided to restructure the NPOS program and break the program up into two, one with the Air Force handling the early morning orbit and NOAA handling the afternoon orbit. NASA is the acquisition agent for the afternoon orbit for NOAA for the JPSS program. And NOAA and NASA have 40 plus years of working together in building weather satellites and through the POS and GOES programs. So relying on that 40 plus years of cooperation and collaboration is what we're going to fall back on in this new regime for the JPSS system.
I would like to give you kind of a real life aspect of how this has improved the situation greatly for NPP. Under the old NPOS program, when we were doing specific like testing for the NPP satellite, where you brought in all the segments and all the parties, flight hardware, ground hardware, and we would have an issue during this test, I, as the NPP project manager, would have to work with the NPOS program, which was a tri-agency group that NOAA had functional responsibility to, but the contracts were Air Force contracts out of SMC, Space Missile Command in California, and the prime contract was with Northrop Grumman in LA. And then each of the instrument contractors and the ground contractors then had contracts with Northrop Grumman. So you could see if I needed something work, I had a pretty big loop in order to go around to make that happen. After the reorganization now, I can tell you that all of those groups, the ground, the flight, live in the same building. And the project managers of those organizations used to be my deputies. So if I have a problem, not only is it easy, it's usually being worked before you ever even ask them. So it's really what's enhanced NPP to stay on schedule for this time and produce a quality product to be launched on October 27th.
Okay, we have one other question on the phone lines. Mark Carreau from Aviation Week. Please go ahead, Mark.
Thank you. I have a question and a follow. Could you tell us the cost of this mission and what's the current projected launch date for the JPSS operational system? I read 2014.
Okay, well, I'll address the cost question. The MPP mission is, the cost of the MPP mission is just over $1.5 billion. And that includes both the NASA costs for mission management, for project management, for the spacecraft and launch vehicle, and the two instruments that NASA provided. And it also includes the costs of the NOAA and DoD provided instruments.
Okay, we have a question here in the audience. Please identify yourself.
Titus Ledbetter from the publication Inside the Air Force. Can you describe the nature of the Air Force's involvement in NPP at this point?
Well, the Air Force was part of the NPOS program, which was responsible for half the funding for the three of the instruments that we were talking about, CRIS, OMPS, and VIIRS, and also the ground system, the data products and algorithms and all of that. And in the beginning of 2010, when it split apart, Air Force went on their morning orbit and NOAA and NASA went in the afternoon orbit. We're still working very close with them. All the data that is produced by NPP goes through this, what we call a common ground system, and Air Force has access to all that information. The same way when they eventually get around to their morning orbit, we will have access to that information. So all the agreements that were in place for these agencies to share this data across these orbits is still in place.
And
Have called for the possible cancellation of the Defense Weather Satellite System. I was wondering your thoughts on how such a move might affect the Joint Polar Satellite System and projects moving forward.
Yeah, I guess for JPSS questions, maybe we could take those offline and get somebody who's better versed in the JPSS program to answer those questions.
Again, those are different contacts we can get you there. The panel is not on the JPSS system, so we can get you people to talk to after this, if that's okay. We have another question online. Doyle Rice from USA Today. Go ahead, please.
Oh, yes. I think most of my question was already answered, but I just wondered how soon.
I think all we heard was how soon. Could you repeat your question?
Right. After it's launched.
Could you repeat the question?
Yeah. How soon after it's launched will it become operational?
You want to answer that?
Yeah, we have it depends. There's over 30 data products from NPP. We've been saying, we expect to have some operational data within 18 months. My guess is from looking at things that there'll be a spectrum and the most critical data sets will be done much sooner. So we're looking at, for the first data sets, probably in the 6-month time frame for microwave radiances and longer for the more complicated data products.
And if I could add, and also with respect to the working with the Air Force, NOAA, NASA, and DoD partake in the Joint Center for Satellite Data Assimilation, and we've been working together to first use AIRS and then go to the MEDOP and use those data sets, and we are preparing for the NPP. So as soon as this data goes through engineering checkout and calibration, validation activities, we'll be relying on the ground system work that's already been done. And the Air Force, the Navy, us, will all be working together for the data assimilation into the numerical models, which we use for all our prediction activities. So we're setting up for that, and we're really looking forward to getting through the CalVal, the instrument CalVal process, so we can start testing it within our models. And like was indicated here, probably, hopefully within the 6-month period, we'll be testing those data sets within the numerical models.
Okay. I guess we have another question here in the audience.
Just to follow up on the budget question, it may be obvious, but I'm not aware of the actual answer. Is the budget for the MPP independent of the NOAA budget for the JPSS and its difficulties that it's had in the past and may continue into the future?
I'm not completely clear on the question, but I believe that the cost of the mission that I provided earlier was both the NASA costs and the NOAA costs that were for the VIIRS, CRIS, and OMPS instruments that were delivered from the MPOS-IPO, and knowing that NOAA shared the cost of those instruments with the DoD during that time frame.
Okay. Okay, we have a question online that I'll have to read as we're having some phone difficulties. It's from Climate Wire, Lauren Morello. Will the design of the instruments, the 5 instruments on NPP, be repeated for JPSS, and how long will they last?
That's a very good question. A lot of work has been done in that area. As I mentioned early, there were significant anomalies during the manufacturing and testing and calibration of these instruments. I know for a fact the JPSS organization, the instrument organization, has spent the last year and a half going through all the requirements, all the design requirements, mission assurance requirements, the way they want to test, the way they want to calibrate, lessons learned from NPP, and are systematically fixing the things that I had mentioned that could preclude on-orbit lifetime of these instruments. So how long will they last? Once again, that's hard to tell, but I can tell you a lot of improvements are being made on these instruments based on the lessons learned from NPP, and the JPSS program is doing that.
Okay, we have one question we received today from one of our followers on Twitter. Simple question. NASA has launched 3 satellites this year from Vandenberg Air Force Base in California. Why does NASA launch satellites from Vandenberg when you've got a perfectly good launch site on the East Coast?
The satellites that are launched from Vandenberg go into a polar orbit. So they're launched so they go over the poles. And because the Earth is spinning, if you want to put things in a polar orbit, you want to go as high a latitude as you can so you can overcome the force of the Earth spinning. So you can put satellites in polar orbit from the East Coast, but it just takes a much larger, more expensive rocket.
Okay, thank you. I think that's all the questions we have from the phone line and here from the press. So let me remind everyone that we have a lot of information online. Continue following NPP up through launch. The website again is www.nasa.gov/NPP. And that concludes our briefing for today. Thank you all for listening.